All right, so if we're simplifying square root of negative 81, the first two examples I am going to show each step, but for the rest of the examples, we're kind of skipping writing down a little bit of it because we don't really need to take the time to do that. So when we see a negative under a radical like this, we know it's not a real number, so we know we're going to need to rewrite it as an imaginary number. Here's how we do that. Square root of negative 81 can be rewritten as square root of negative 1 times 81. So what we're really doing, the actual math we're doing, is we're rewriting the negative number as negative 1 times that number. So I have square root of negative 1 times 81. Since these are multiplied, I can put each of them under their own radical. So then I would have square root of negative 1 times square root of 81. Okay. So as we hopefully know, square root of negative 1 is I. So square root of negative 1 can be replaced with I, and square root of 81 is still under the radical. However, in this case, square root of 81 is a whole number. It's a perfect square. So square root of 81 is 9. So we can write this as I times 9, but usually we'd see it in the order 9i. So the big key thing here, we wrote down the in-between steps, but the negative under the radical became the I outside the radical. All right, let's look at number 2. So write down number 2, square root of negative 55. And we're trying to simplify that. So anytime we see a negative under a radical, I know I need to rewrite it with an I. So again, here's the process. Square root of negative 55 can be rewritten as square root of negative 1 times 55. And then because they're multiplied, I can put them each under their own radical. So we have square root of negative 1 times square root of 55. The stylus is not working very good. Square root of negative 1 times square root of 55. And once again, square root of negative 1 is I. In this case, square root of 55 is not a perfect square, so it would stay under the radical. So you can write it as I square root of 55, or you can write it as square root of 55I. The key thing to notice, though, is that the I is not under the radical. So both are correct. If you write it the second way, make sure the I doesn't look like it's under the radical, because only the 55 should be under the radical. That's why we usually see the I in front, so it's clear that it's not under the radical. But like I said, both are correct. So once again, the key thing here, the negative inside the radical, I rewrote it as a negative 1, put it under its own square root, and it became an I. Now, when we do this, we're typically going to skip these middle two steps in blue right here, because we shouldn't have to actually write that out every time. We should just be able to go from here, the negative on the inside, to the I on the outside. So that's what I'm going to do on the rest of the problems that we're going to see. I'm going to do the negative. I'm just going to change the negatives on the inside to the I on the outside. All right, so let's do example 3. So write down example 3. is square root of negative 98. Square root of negative 98. Okay, so as I said, I'm going to not write down the middle steps. As soon as you see a negative under a radical, you should be able to write it as an I outside the radical. So this negative becomes the I on the outside. The 98 is still under the radical. So here's what we have so far, I square root of 98. Now on this problem, we are not done because the square root of 98 can simplify more. So hopefully you remember how to simplify radicals. You've seen it in Algebra 1, Algebra 2, geometry, and we reviewed it in R1. So you can always go back and watch the videos from R1 if you missed those lessons, but we do need to know how to simplify. All right, so now I need to simplify the square root of 98 part. Remember, to simplify a radical, we want to make a factor tree. So I'm going to break this down into prime factors. I need some factors of 98. I know since it's even, I know 2 goes into it. So 2 goes into 98 49 times. So 2 and 49. 2's prime. 49 can break down to 7 and 7. Okay, so now 7 and 7 are prime. So hopefully we remember when we're simplifying a radical, we're looking for pairs. So I have a pair of 7s. Remember, that's 7 squared. And then I have the 2 left over. This is, since it was square root of 98, these are under a square root. So the square root of 7 squared, the square root and square get rid of each other, so that just becomes 7. But the 2 was not squared. It was not in a pair, so it stays under the radical. So remember, if you have a pair, it goes on the outside. So we have a 7 on the outside. And then the 2 that was by itself is on the inside. Right? So that's how the radical simplifies. Don't forget, though, that we still had that I in the front, which is still part of our answer. Okay, so I times 7 square root of 2. No, it doesn't matter what order you write it in. So if you wrote it in this order, that is fine. A more common order is like this, 7I square root of 2. That's probably the most common way to write it. Or you can also write it as 7 square root of 2, I. Again, the I, though, if you write it this last way, the I is not under the radical. So all 3 of these are the same. I 7 square root of 2, 7I square root of 2, or 7 square root of 2I. Okay, so I don't care which way you write it. They're all correct. The middle one that I highlighted is the most typical. Okay, so again, if you see the negative under the radical, right away switch it to an I outside of the radical. So I skipped the steps for that. I just put it as an I, but I did simplify the radical, the square root of 98 part. Okay, number 4. Write down number 4, example 4. Number 4 is square root of -5 times square root of -30. We are going to have to use some of our rules for radicals here, specifically that I'm multiplying. So remember, with multiplying and dividing, you can only multiply things if they're either both inside the radical or both outside the radical. Now, before I multiply this, notice they're both negatives. So both negatives in the radical have to be rewritten. So I have to rewrite both of those, and then I'm going to multiply them together. So on this one, square root of -5, I would write that as I square root of 5. So again, the negative on the inside becomes an I on the outside. The square root of -30, I write that as I square root of 30. Okay, so the negative there on the inside became the I on the outside. Right now, the 5 and the 30 are both inside. All right, now I'm multiplying these. So to multiply, I can multiply what's on the outside together. So on the outside, I times I is I squared. And on the inside, 5 times 30 is 150. So that would be square root. It'd still be under the square root, under the radical. So I squared square root of 150. Okay. We are partway done, but now I need to simplify both of these things. So I squared, remember we said just a bit ago, I squared is equal to -1. So I would replace the I squared with -1. Now the square root of 150, we have to simplify. So I have to break this down like I did on problem 3. Anytime we can, we want to simplify our radicals. So I'm going to find some factors of 150. Let's see, I can use 10 and 15. Neither 10 nor 15 are prime. So 10 can break down more to 5 times 2, and 15 can break down more to 5 times 3. Okay, and remember with square roots, we're looking for pairs or squares. I have a pair of 5s, and then I have a 2 and a 3 left over. So when I'm writing that, the 5 from the pair, or the 5 squared, is going to simplify to just 5 on the outside. The things that are not in a pair, the 2 and the 3, are going to stay on the inside. So on the inside, 2 times 3 is 6. Okay. So the I squared part simplifies. So that's the part in purple simplifies to -1. And the part in red, square root of 150, simplifies to 5 square root of 6. Now, for my final answer, instead of writing -1 times 5 square root of 6, I can multiply the -1 times the 5. And that would be just -5 square root of 6. So notice after we simplify, there's not an I in our answer anymore. There's no more imaginary. It's actually a real number because I squared simplified to -1. Okay. So that was number 4. That was multiplying. We rewrote the radicals with i's first, and then we multiplied together. All right, we're going to do 2 more. Now, if you look at the problems on 5 and 6 that we're going to do, these are the types of answers we're going to get when we're using the quadratic formula, which is actually going to be in our next section. So it is really important to be able to simplify things like this. And in just a minute, when we do some practice problems, we'll talk about how we actually type that, or how we're going to type it. All right, so 15. So let's look at number 5. So write down problem 5, please, in your notes. And we're trying to simplify 15 minus square root of -75 all over 5. 15 minus square root of -75 all over 5. Okay, so the fraction bar we see here is going to mean divide. We're dividing by 5. Now, one thing to notice here, or I guess I should say a common error, one thing to look out for is sometimes people want to just divide first. I'm not going to divide first. People try to divide the 15 by 5 and the 75 by 5. The reason that's not correct is because the 75 is under a radical, square root of 75, and the 5 is not. So I can't divide those. So I don't want to divide the 15 either, because both of them are over 5, not just one of them. So that means the first thing I need to do is I need to simplify the radical part. So I need to simplify this part first. Always simplify your radicals first. I'm going to do that off to the side right here. We have square root of negative 75. Okay, so first thing I would do if I'm simplifying, I would rewrite this. It's a negative under a radical, so I would write it with an I. So I have I on the outside, and square root of 75 is still under the radical. Now I need to simplify the square root of 75. That's where we use the factor tree. On the previous two problems, I made my factor tree going sideways. Here, I'm making it going down. It doesn't matter how you do it. So some factors of 75, obviously 5 goes into it. So 5 goes into 75, 15. 5 is prime, but 15 can be written as 5 times 3. So then I have a pair of 5s and a 3 left over. So when I write that, the one from the pair goes on the outside. So I've got a 5 on the outside, and then the 3 stays on the inside. So 5 square root of 3. Now, don't forget, we still have the I in the front. So square root of 75 simplifies to I times 5 square root of 3. So now that I simplified the radical part, I'm going back to the whole problem right here. So I'm going to rewrite this. I'm going to have 15 minus, instead of square root of negative 75, I'm going to write it as 5i square root of 3. Again, the order you write that in doesn't really matter. And then the whole thing is over 5. Now I can actually divide. So remember, we couldn't divide the 75 by the 5 because it was under the radical. But now I will be able to divide this 5 by the 5 because they're both outside the radical. I won't divide anything with the 3 because it's still under the radical. Okay, so now let's actually do the division. When something is, when the whole thing is over 5, it means both parts are divided by 5. So I have to divide both parts by 5. So I'm going to have 15 over 5. That divides to 3. And right here, 5i square root of 3 divided by 5. The 5s will divide out. 5 divided by 5 is 1. So you don't really have to write the 1, but it's going to divide out. And we're going to be left with I square root of 3. So that's what our simplified answer looks like. 3 minus I square root of 3. So as we can see, it definitely looks simpler than the original one. So like I said, in the next section, we're going to be using the quadratic formula. And most people can plug in the numbers, but we also need to be able to simplify. So to be highly proficient, we should be able to simplify something like this. Okay. This is going to be our last example. Then we'll take a short little stretch break, and then we'll do practice problems with all of this stuff. Okay, so last example, then we'll be done with the notes for today. We'll have to finish tomorrow. All right, so write down number 6. -8 plus or minus the square root of -44 divided by 4. -8 plus or minus the square root of -44 divided by 4. Okay, so let's simplify that. So I have a fraction bar, so I know I'm going to be dividing by 4, but I cannot divide yet because even though the 8 is divisible by 4, I can't divide the square root of -44 by 4. So before we try to divide anything, we always, always, always have to simplify this. So let's simplify the radical part. I'm going to do that off to the side right here. So I have square root of -44. All right, the negative under the radical, that becomes an I. And then the 44 is still under the radical. So square root of negative 44, I rewrite as I square root of 44. But let's simplify the square root of 44 part now. Let's break this 44 into prime numbers. It can be 4 times 11. 11's prime, but 4 can break down to 2 and 2. Okay, so I have a pair of 2's and an 11 left over. Remember, the pair goes on the inside. It doesn't have, or I mean, the pair goes on the outside. It doesn't have to do with which one's bigger. Only things in the pair can go outside. So this would give us 2 on the outside and then square root of 11 on the inside. And then don't forget, we also have that I on the outside. So square root of negative 44 simplifies to 2I square root of 11. Okay, so back to the whole problem now. Coming back to here, I'm going to rewrite the radical to what I just simplified. So I have negative 8 plus or minus 2I square root of 11 over 4. So let's talk about if we can simplify that anymore. And this we actually can. There's 2 ways we can think of this, and I'm going to show you both ways. One way is, remember, this entire expression is divided by 4. So I don't want to just divide the 8 by the 4 unless I can also divide this term, the 2I square root of 11 by the 4. Notice that the 2 and 4 don't divide evenly, but they would be able to reduce. So one method is that we can reduce this. The way we reduce is we just look for a common factor of the numbers that are not under a radical. Here, 8, 2, and 4 all have a 2 in common. And we can divide out a 2 out of all of those. That's one way we can reduce, is we can just leave it as a fraction, but divide a 2 out of all of those. That will give us a negative 4 plus or minus. This would divide to give us a 1I square root of 11. I don't really have to write the 1, so I'm not going to write the 1. So just I square root of 11 over 2. So notice if I write it this way, it's still written as one single fraction. So negative 4 plus or minus I square root of 11 over 2. So I reduced everything, but I didn't actually divide them. Another way we could do this, since the whole expression is over 4, I could write each part over a 4 separately, like this, negative 8 over 4 plus or minus 2I square root of 11 over 4. So divide each part by 4. The reason some people prefer this is because you might notice the negative 2 divided by 4, or sorry, the negative 8 divided by 4 divides to give us a negative 2. The second part, the 2I square root of 11 over 4 doesn't divide, but it can reduce. The 2 and the 4 can reduce to a half or a 1 over 2. And so that part gives me I square root of 11 over 2. So here's another way you can write it. This is just splitting it into 2 separate parts by dividing each part by 4 separately. So either you could reduce the whole thing, or you could divide them separately and reduce separately. All right, so both of those are correct, and it doesn't really matter which way you write it, at least when we're dealing with quadratic equations like we will in the next section. Okay, so I know that was kind of a lot of notes at once, and I do want to do some practice problems, but I also, before we do practice problems, I want to give you